Hi guys, so a quick lesson on instantaneous rates of change for a function. Okay, so again, when we're talking about the instantaneous rate of change, we're talking about it at a particular moment. So like if I was trying to capture the speed of a racehorse coming across the line, I'm trying to stop the motion at that exact point and work out the speed of the horse. Okay, so we're going to do that by looking at a couple of different things. So you need some terminology. A secant is a straight line that passes through 2 points. So I can see here this is going through 2 points on a curve or a circle in this situation. So there are my 2 points and it's just a straight line. Okay, a chord then is a segment of a straight line. So if I was to look at my blue line and extend it on, it's just a straight line, but the chord part is when I'm talking about the segment that's cut off from the curve. So that section there where it's cut off with the curve. And a tangent is a straight line that touches a curve at 1 point. Okay, so this here is my tangent and it's cutting it at that point there. Okay, I could have another tangent here at this point going like so, so it only touches the curve or circle at 1 point. Okay. Instantaneous rate of change, again, it's a point on a curve and that we're trying to work out what the rate of change is. So what we do is we work out the slope of the curve at that point. Okay, so in order to determine the instantaneous rate of change, we work out the slope of the curve at that point. Okay, so the slope is the measure of the tilt, so we're talking about the gradient obviously. So now instantaneous rate of change gives us the slope of the tangent line at a single point. So when we were doing average rates of change, we looked at 2 points and we worked out their average by doing y2 take y1 over x2 take x1. But when we're doing instantaneous, we want to know just exactly at 1 point, so we have to draw a tangent line. So if I'm talking about point P here, my red line is my tangent line and I'll work out the slope of that line, and that should tell me the slope of this point in particular. Okay, I could do the same for this point here, work out the tangent line, so my tangent line would be something like that. So again, I can see that at this point here my slope is a little bit steeper than at point P. Okay, so my tangent should be a little bit steeper. At this point here again, my slope is a little bit steeper, so again this tangent should be steeper than the last one I drew, and etc. Okay, so the secant was when we were trying to find the difference between the 2 points. The tangent is when it's just at an instant point. Okay. Given the graph of f of x is equal to x squared, so as shown below from 0 to 5, so I'm talking about from 0 to 5, find the rate of change at x is equal to 3 by drawing a tangent. So if I look at my point x is equal to 3, I'm talking about this point here, and I want to draw a tangent. It's kind of hard on this app, so I'm just going to erase what we've already got. So if I was to draw a tangent, it would look something like this. Okay, and that's going to give me the tangent at point 3 when x is equal to 3. Okay, and it only touches it at that 1 point on the curve. Okay, and now what I'm going to do is I'm going to work out the gradient of this tangent, and when I work out the gradient of this tangent, that will tell me the gradient at this exact point. Okay, so again, change in y over change in x. So if I choose my 2 points on the tangent this time, because I'm trying to find the slope of the tangent, which is then going to give me the slope of the point. So if I choose, let's say, if I was to choose 2 and that point there, so it's about 2, 3. In fact, I could even just take this point here, which is 3, 9. Okay, so 3, 9 as one of my points. And then another point on the tangent, I could try maybe 5, 20 or 5, 19. So I'll go with 5, 20. And there are my 2 points on the tangent. And when I work out the gradient of the tangent, that's going to give me the gradient of the point at that time. So m is equal to 20 take away 9 all over 5 take away 3, which is equal to 11 over 2, which is equal to 5.5. So the gradient of the tangent line is equal to 5.5, which means the gradient or the steepness of the curve at the point x is equal to 3 is also 5.5. Okay, so you work out the gradient of the tangent, and that gives you the steepness or the slope of the curve at that point. Okay, you could do the same for point x is equal to 4. So there's your point, draw a tangent. So again, try and have it as accurate to the tangent to the point as possible. Choose 2 points on it, and then work out the gradient of the tangent, giving you the gradient of the point on the curve x is equal to 4. Okay, and that's basically all we need to take away from it. There's an example of how to use it on your CAS in your textbook, so give it a go. Thank you.